Ever wish you could like predict the future? I know I do, especially when it comes to the stock market. But hey, today we're diving into something almost as good.
Almost as good, huh?
Okay. Maybe not as good as predicting the winning lottery numbers, but still pretty useful. We're talking about ARIMA models. You've sent us some really fascinating research on this, so get ready to learn all about using the past to maybe catch a glimpse of what's coming next.
You know how detectives use clues to try and piece together what happened, right?
Yeah, like those detective movies where they're like, he couldn't have gotten to the window, the timeline doesn't add up.
Exactly. So ARIM is kind of like that, but instead of solving crimes, we're looking for patterns in data to make predictions.
Okay, so let's break this down for our listeners. ARIMA stands for Autoregressive Integrated Moving Average.
It's a mouthful, right?
It does sound kind of intimidating.
But it's not as complicated as it sounds, I promise. The heart of it is, ARIMA is really good at finding connections in data collected over time.
So we're talking about things like stock prices, sales figures, maybe even like weather patterns, right?
Exactly. ARIMA takes those historical patterns and it kind of says, okay, based on what's happened before, here's what we can reasonably expect to happen next.
And this works especially well when we're talking about making predictions about the near future, right?
Right.
Short-term predictions.
Absolutely.
Oh.
Think about it this way. If you had to guess tomorrow's temperature just based on, let's say, the past week's weather, you'd probably have a decent shot, right?
Yeah, unless some crazy weather front suddenly rolls in.
Right. But assuming things generally stay the course, you can make a pretty educated guess. And ARIMA is similar. It's really good at making those kinds of short-term forecasts using patterns from the past.
Okay, I think I'm starting to get it. But now let's go back to that kind of scary acronym, ARIMA. How about we break that down, like piece by piece?
Sounds good. Let's do it.
Okay, so first up is AR, which stands for autoregressive. So what's that all about?
Okay, so autoregressive basically means we're looking for relationships between a value at a specific time and its own past values. It's like, does yesterday have anything to do with today?
So like if yesterday's closing stock price was high, ARIMA might say, there's a chance it might be high again today.
Exactly. Now, the next part, the I, which stands for integrated. This is all about making sure our data is stationary.
Stationary? Is that anything like when like my old car just refuses to move no matter how much I plead with it?
Haha. Not exactly, though I do feel that pain.
Yeah.
In the data world, stationary means the statistical properties are pretty consistent over time. Imagine like a river flowing at a nice, constant level that's stationary. No crazy rapids or sudden drops.
So for ARIMA to work, we need that calm, steady river, right?
Exactly. We don't want our data to be all over the place. No drastic shifts or trends.
Because those trends would really mess things up.
They could, yeah. It's kind of like we need to iron out the wrinkles of the data first.
And that's where that integrated part of ARIMA comes in, to get things all smoothed out.
Exactly. To get it ready for analysis.
Okay, so we've tackled AR and I. Now we're at MA, which stands for moving average.
Right. And you know how everyone loves a good comeback story?
Oh yeah, those underdog stories for sure. What does that have to do with ARIMA?
Well, even our ARIMA models can have a bit of a comeback story. They're not perfect, right? They're going to make some wrong predictions from time to time. But the MA part is all about learning from those mistakes.
Like learning from our past mistakes to make better decisions in the future.
Yep. It's basically saying, hey, we might have been off a bit here and there, so let's use those errors, factor them in, and maybe we can do even better next time.
So it's ARIMA is constantly learning and adapting, kind of like fine-tuning itself as it goes.
Exactly. So let's say we're trying to predict how many of those cool new phones everyone's talking about a company is going to sell. ARIMA takes past sales data, figures out the trends, smooths out any weird bumps or inconsistencies in the data, and then tries to make an educated guess about how those sales might look in the next few weeks, maybe even a few months out.
Okay, that makes a lot more sense now. So it's not about predicting like the distant future, but more about using those patterns to make smarter guesses about the near future?
Exactly. It's all about making those short-term predictions more reliable.
Okay, so we give ARIMA a bunch of data and it spits out a prediction. But how do we actually build one of these models? Is it just plugging some numbers into a spreadsheet, hitting enter, and hoping for the best? So it's not quite as easy as hitting enter on a spreadsheet.
Not quite, but hey, it's not like we're launching rockets here.
Okay, good, because my spreadsheet skills are way stronger than my rocket science skills.
Mine too.
Yeah.
But anyway, to stick with that whole stock market example,
Yeah.
let's say we want to build an ARIMA model to like I don't know, maybe get a little edge in the stock market.
Who doesn't want an edge in the stock market,
Right.
right?
So, step one, gather all that historical stock price data, as much as you can get your hands on.
Data, it's like the fuel for these ARIMA models.
Exactly. The more data, the better. And once you've got all that data, you'd want to plot it out visually, see what's going on, any big jumps or dips. You're looking for those trends, trying to get a feel for how that stock generally behaves.
So, like, are we talking to the moon kind of trends or more like time for a nap trends?
Exactly. You got it. We want to see the whole story. And this is where getting a handle on autocorrelations can really come in handy.
Okay, more big words. Hit me with it. What's an autocorrelation?
It's simpler than it sounds. Basically, it tells us how much a data point is related to its past values.
So, like, if yesterday's stock price was super high and today's price is also high, that's a strong autocorrelation.
Boom. Exactly. You got it. And by looking at these autocorrelations, we can figure out how much differencing. Remember how we were talking about ironing out the wrinkles?
Yeah, to get that nice, smooth data.
Right. We can figure out how much ironing we need to do to make our data stationary.
Smooth data for a smooth ARIMA ride. Got it.
Now we're getting into the nitty-gritty. Lag order and moving average window. Don't worry too much about memorizing those terms, but they're basically about choosing the right settings for our ARIMA model.
Kind of like tweaking the dials on a camera to get that perfect shot.
Exactly. So lag order is basically how far back in time our model should look when it's searching for those patterns. Let's say we set the lag order to 5 for predicting our stock prices.
So we're telling our model, hey, you've got the past 5 days of stock prices as your clues. What do you think the stock will do tomorrow?
Exactly. Then you've got the moving average window, which is all about using those past errors, those little hiccups, to smooth things out. It determines whether we pay more attention to recent mistakes or older mistakes.
So it's like choosing how much weight to give those past blunders, right?
Exactly. You don't want to dwell on the past forever, right?
Mm.
And remember, the more data we can feed our model, the more reliable the patterns become, and the more confident we can be in our predictions. And that's one of the reasons why ARIMA often goes hand in hand with computer algorithms and machine learning. We need that extra brain power to really crunch those massive amounts of data and make sense of it all.
Yeah, it sounds like ARIMA modeling could be a full-time job in itself.
It can be. But even with all those fancy algorithms and powerful computers, we got to remember, ARIMA models, just like any predictive tool, well, they aren't foolproof.
So even with the best data and the smartest algorithms, sometimes those predictions just miss the mark.
It happens.
Everyone has an off day, I guess, even our fancy ARIMA models. So what are some of those limitations we should keep in mind?
One of the biggest ones is that while ARIMA is great for short-term forecasting, like we were talking about, the further out we try to predict, the less accurate it tends to become.
Yeah, like predicting tomorrow's weather is probably a lot easier than predicting what the weather will be like a month from now, right?
Exactly. There are just too many factors that could come into play over a longer period. The same goes for other kinds of data. Unexpected events pop up, trends change, new information comes to light, and those are things that ARIMA might not be able to anticipate just by looking at past data.
Right, like trying to predict the stock market using data from like before the internet even existed.
Exactly. Things change. The game changes. And that's something to keep in mind with ARIMA. It's relying on those historical patterns. And sometimes, well, the future just doesn't care about the past.
So are you saying those unexpected events, those curveballs that life throws our way, those can really mess with even the most carefully crafted ARIMA model?
You got it. And that's why, even though ARIMA can be super useful for understanding patterns and making those short-term predictions, it's super important to remember every model is just a simplified version of reality. And reality tends to be a lot more complex and unpredictable.
It's like that old saying, past performance is not indicative of future results, right? Just because something's happened a certain way before doesn't mean it always will.
100%. We can't rely solely on the past to predict the future, but it can definitely give us valuable insights. And while ARIMA is really good at finding those correlations, those connections in our data, there are other ways to approach time series forecasting, other tools in the toolkit, so to speak.
Oh, other tools. Now you've got me intrigued. Tell me more about these other forecasting tools.
Okay, so we've spent a lot of time talking about ARIMA, which is like our super sleuth for finding patterns in data. But you mentioned there are other forecasting tools out there, other ways to get a glimpse into the future. What else is in our forecasting toolbox?
Well, one of the other heavy hitters in the forecasting world is called exponential smoothing. And it takes a slightly different approach to analyzing those time series.
Okay, so If ARIMA is all about those correlations and kind of like zooming in on the bumps in the data, what's exponential smoothing's thing?
So exponential smoothing is really into trends and seasonality. It puts more weight on those more recent data points, kind of like it's saying, hey, the recent past is probably a better predictor of the immediate future than stuff that happened ages ago. So if we were trying to predict something like, let's say, ice cream sales, exponential smoothing would pay extra attention to those hot summer months when sales are usually through the roof.
Exactly. It's like it's focusing on that smooth flow of the data, following the general direction, rather than getting bogged down by every little blip along the way.
So it's kind of like ARIMA is our detail-oriented detective with a magnifying glass, while exponential smoothing is taking a step back, looking at the bigger picture.
That is a fantastic way to put it. And while they have their differences, both ARIMA and exponential smoothing are super useful tools for forecasting. In fact, sometimes the best approach might involve using both of them together, combining their strengths.
A dynamic duo of data prediction. I like it. Now, earlier you mentioned a couple of interesting real-world examples of ARIMA in action. Did any of those from our listeners' research particularly catch your eye?
There were a couple of really good ones. One that stood out to me was that study that used ARIMA to analyze European quarterly retail trade data. They were trying to understand those patterns in retail sales, maybe even get ahead of the curve and predict future consumer demand.
So using data to figure out what people are buying and when, that's super valuable information for businesses, right?
Oh, absolutely. It's like trying to predict whether people are more likely to be shopping for swimsuits in January or July, right? Past trends can give us those clues. And speaking of important trends, another really cool example was that study on using ARIMA to model those monthly sales of corticosteroids in Australia.
Okay, so in that case, they were looking at past medication use. And I'm guessing trying to anticipate future demand to make sure that patients could actually get the medicine they needed. That's amazing.
Right, we're talking about a real world impact here. And those are just two examples from all that great material you shared. But they really highlight how versatile ARIMA can be, how it can be applied across different fields and industries.
It's pretty amazing what we can learn just by digging into the past, isn't it? But let's say we've built our RIMA model, we've fed it a mountain of data, and we're getting our predictions. How do we actually know if it's any good? Like, how do we grade its performance?
That is a great question. That's where analyzing the residuals comes in. Think of the residuals kind of like leftovers, the difference between what our ARIMA model predicted would happen and what actually happened.
Okay, so if we predicted we'd sell 100 widgets, but we only sold 95, those five missing widgets, those are our residuals.
Exactly. You got it. And we can learn a lot from those leftovers. Ideally, those residuals should look pretty random, like someone just sprinkled them around. But if you're seeing patterns in the residuals, that might be a sign that our model is missing something.
Like finding those stray crumbs after you thought you'd clean the kitchen counter. A sure sign you missed a spot.
Exactly. And there are even some statistical tests we can run to check for those lingering patterns in the residuals, just to be extra sure.
So it's like giving our ARIMA model one final exam to make sure it's really mastered the material.
Precisely.
Well, it has been quite the journey, hasn't it? We've explored the world of ARIMA models, from breaking down that intimidating acronym to seeing how they're used to solve real-world problems. As we wrap up, what's the one key takeaway you hope our listeners will remember as they embark on their own data adventures?
I think the most important thing to keep in mind is this. ARIMA is a super powerful tool. It can help us uncover hidden patterns and make informed decisions about the future. But at the end of the day, no prediction is ever foolproof. The future is always full of surprises.
And maybe that's what makes it all so fascinating, right? That element of the unknown.
Absolutely.
Well, on that note, I think it's time to wrap up our deep dive into the world of ARIMA modeling.
It's been a pleasure exploring with you.
And to all our listeners out there, thank you for joining us on this journey. We hope this episode has equipped you with the knowledge and the inspiration to unlock the secrets hidden within your own data. Until next time.